lesson 9.1. So when you guys go on, you should be able to view my printed lesson plans, okay? So I'm not going to write everything because you have it, right? Or should be able to see it. So 9.1 is inverse and joint variation, okay? Back in a previous lesson, we have learned about direct variation, I think back in chapter 2, okay? And that's what this y equals kx is. It says that they vary directly as x is getting bigger, y is getting bigger, or as x is getting smaller, y is getting smaller, and k is that constant of variation, okay? So we did that back in chapter 2. That's a linear variation, right, if we were to graph it, okay? Chapter 9, inverse variation, okay, is we say two variables vary inversely if they relate as follows. So y equals k divided by x. K is going to be the constant of variation, just like it was in the past, okay? And now you're dividing by x, right? So it won't be defined when x is 0, because when you divide by 0, it's undefined. Okay, so it's not going to be a linear relationship then. So we can write two generalized equations then for direct and inverse variation, right? Because direct variation says y equals kx. So k will equal y divided by x, and this will be constant. Right? And that's for direct variation. Then inverse says that y equals k over x. So our constant then will be y, or x times y, for all x and y in the relationship. Okay? So if this is true for all x and y, that they equal the same constant, we can say it's direct. If k is equal to the product of all the x times y and they're the same constant, then we say it's inverse variation. Okay, so then we can look at some examples and decide if the relationship is direct or inverse. Right, so going back to your notes, so if we say that x times y equals a constant, then that tells us, solving for y, because that's what we always do, y is going to be the constant divided by x. So this happens to be then inverse variation. Right, if we look at the next one, we're saying that x is equal to y divided by 1.5. So if this is direct or inverse variation, we can decide by getting y by itself. So we multiply by 1.5. So then y equals 1.5 times x. And now it's a product of x times a constant, so this is direct variation. Okay? But then something like the last one, y equals x plus 5, it doesn't fall into either one of these. Yes, it has x times 1, but you're adding something. So this is not direct, and it's not inverse. So this is neither type of variation. Okay? So the other thing you can do is you can write an equation that relates x and y if you know what kind of variation it is, and if you know an x value for a given, or know a y value for a given x, right? So x and y vary inversely. Right? So they vary inversely. That tells us that then y equals k over x, because it's an inverse variation. Okay, great. So that's the first step. Don't know what any of them are yet, but we know that they vary inversely. Okay, then we know that when y equals 6, x equals 1.5. Okay, well, it's inverse variation, and we know these two things to be true. So we can say that 6 equals k divided by 1.5. Right? To write an equation, we need to know k. Well, it's our only variable left, or our only unknown. So we're going to solve for k by multiplying by 1.5. So 6 times 1.5, k equals 9. Right? That's not our equation though. Okay? So you need an equation, but you now know they vary inversely, and you know k. So we can say that then y is going to be 9 divided by x for all x and y in this relationship. Then you can find y given an x value. Right? So if x equals 4/3, find y. Well, you now have your equation. Okay? So then y equals 9 divided by 4/3, which equals 27/4. Okay, all because we knew that x and y varied inversely. All right. So back to what I just said, right? We know that inverse variation tells us that y equals k over x for all x and y in the relationship. So k will equal x times y for all xy. Okay, so you can use that to tell if data is an inverse relationship. Okay, so looking at the example, right, you have values for w and for h. So we want to know if these are an inverse relationship. So to do that, we're going to find out if the product of w times h equals k, meaning they all equal the same constant. If they do, then it's an inverse relationship. So I'm going to add in an extra row here. Here's our original data. Okay, so I'll add in one more row for k, because inverse relationship, we need k. And we're going to find out if k, we're going to do w times h for all of these points. So 2 times 9 is 18. 4 times 4.5 is 18. 6 times 3, 18. 8 times 2.25, 18. 10 times 1.8, 18. Okay, this number is the same, so they all equal some constant. They all equal the exact same constant. So then it is an inverse relationship. So y equals kx is an inverse relationship, but you just found k because it's the same for all of them. So we can then say y equals 18 over x. And that's our inverse relationship. And actually we're going to use w and h, right? So let's put h, w. So h is 18 divided by w, because that's our variables here. Okay? So that's how we tell if data is an inverse relationship. Right? Check the product of the input versus the output, the x times the y. If it's all the same constant, it is an inverse relationship. Okay? And then the last kind of relationship is something called joint variation. Okay? Joint variation we're usually going to use now when we have three variables. So x, y, and z, for example. Joint variation is essentially direct variation, but for three instead of two variables. Okay, and we can kind of see that right there. Okay, so it just says that one variable varies directly with two or more quantities. Okay. So we would say that z varies jointly. You always have that constant, okay? That's what k is, a constant. It tells us how exactly they relate. So z varies jointly with x and y. Z is going to equal k times xy, because it's saying it is direct variation with two or more other variables. Okay? So then just working through what they all mean, right? Again, looking at your notes, y varies directly. So we would say y varies directly with x. Well, direct variation is k times x, and then inversely with z squared. So the constant, you don't need more than one because constants get absorbed together. So even if you had two of them, you'd put them together and you would get one constant, right? Just like our like terms. So then divided by z squared, because it varies inversely with z squared. Okay? Y varies inversely with x cubed. Well, y varies, that's where our equal sign is going to come from. Inverse variation is division. So there's our constant inversely with x cubed. Okay? Jointly, again, you use it when you have three or more variables. So z varies jointly with x squared and y. Well, jointly just means direct variation for two or more variables. So z varies jointly. So again, there's our constant. Joint variation means a product. So jointly with x squared and y. So we would write it as a product. Okay, otherwise you will see the word inversely when they want you to have division in your relationship. Sorry, that's what I was looking for. Okay. All right. And then you can put it all together, just like the last example, and write an equation given information about your variables. Okay, so if you look at the last page of your notes, the variable z varies jointly with x and y. So z varies jointly with x and y. Okay, we know that just by the first thing that they have told us. So then we're going to use given values to write an equation that relates x and y and z. So just finding k does not mean you have written the equation. That's the first step. Okay, so 1, find k. Right, so they tell us that when x is -12, y is 4, and z is 2. So first we are going to find k. So we know they vary jointly, and then we're going to plug in these values for x, y, and z. So 2 equals k times -12 times 4. solve for k. We get 2 equals negative 48k. Divide by negative 48. Simplify. Do not write it as a decimal. Unnecessary. We get negative 1 over 24. Okay, we are not done. That is the value for k. Once you have the value for k, then write your equation. All right, so that means varies jointly. So z equals kxy. You just found k, so then z equals negative 1 over 24 xy. This is the equation that relates x and y and z. This is what you want. You don't stop at finding k. You write the equation by finding k and then putting it back in. And then you can find a value for z given two different values for x and y. All right, so that is joint and inverse variation. A little bit of direct variation, but we learned that back in chapter 2. And that's your